Thank you for the kind introduction, and thank you all for inviting me to speak here today. It's very much a pleasure to be part of this discussion. The Arctic is a very important part of our industry, so hopefully I can share with you some of our experiences from ExxonMobil. As the introducer said, I'm the lead country manager for ExxonMobil's businesses in Norway. I have 19 years with ExxonMobil, both in our research and production businesses, and I've had the opportunity to work in our industry in a couple of locations around the world. These experiences have helped me understand how we as a company and we as an industry are tackling some very difficult challenges to safely develop oil and gas resources. As we know, the Arctic holds great potential, with the US Geological Survey estimating that 25% of the world's undiscovered resources lie above the 66th parallel. And while the Arctic has not been widely explored, there is a long history of oil and gas activity in Arctic and subarctic environments. It's very interesting. I hear a lot of discussion in Norway about the challenges of the Arctic as if this is something new and untested. But the reality is that the oil and gas industry has more than 90 years of operating experience in these conditions. So we know the challenges can be overcome. As a company, ExxonMobil has a significant interest in the safe and sustainable development of Arctic resources. We believe the Arctic has an important potential to help meet the world's future energy needs. But our success in the Arctic hinges on the ability of governments, local communities, academia, and industry to work together to realize the potential of these important resources. So today I'll talk a bit about our operating history. I'll describe some of the challenging conditions that we've addressed in the projects to date, and share some thoughts about the keys to continued future success. Let me start with why resource development in the Arctic is important. As we look to the future, it's clear that our industry faces tremendous challenges. The world will need reliable and affordable supplies of energy on a scale unprecedented in human history. There are two things that drive this. In 2011, the global population surpassed 7 billion people. By the year 2040, experts project that the global population will grow by 25%, reaching nearly 8.7 billion people. The expected increase in Africa's population alone from 2010 to 2040 is larger than the total population of Europe. Over the next 30 years, we project that economies in OECD countries will grow by about 2% a year, and economies in developing countries will grow by about 4.5% per year. This means the global economy will more than double in size from 2010 to 2040. A consequence of this expansion in population and economic development is that global energy demand will be more than 30% more than what it is today in just 30 years' time. To meet this increasing demand, the world's populations will require all sources of affordable energy, and our efforts must include the development of new hydrocarbon resources across the globe. It's in this context that the Arctic can play a critical role in helping to balance the world's supply and demand needs. We cannot ignore, however, that operating in the Arctic poses challenges. In order to be successful in this extreme weather environment, safety must always be top of mind and embedded in every aspect of exploration, development, and production. Not only do we need to operate safely, but we must also focus on effectively mitigating potential impacts to the environment, communities, and indigenous people. To meet these challenges, Arctic operators must be leaders based on technical expertise, based on robust safety and risk management processes, and proven respect for local cultures. ExxonMobil believes that our industry has a responsibility to pursue operational excellence wherever we do business. Our goal needs to be an incident-free workplace with the simple objective of nobody gets hurt. Within ExxonMobil, we achieve this by focusing on the fundamentals: safety, reliability, operational integrity, and efficiency. All of these fundamentals hinge on effective risk management, which is essential to deliver the results that host governments, our partners, and society expect from us. And while our industry recognizes the importance of risk management and operational integrity, incidents around the world continue to reinforce the need for improvement. Our license to operate is at stake. If we don't ensure operational integrity, we put people's lives, the environment, shareholders' assets, and our reputations at risk. I want to stress that the health and well-being of our employees, contractors, and the communities where we operate is more than just a priority. This is a core value of our corporation. This commitment to the highest standards of safety, reliability, and operational integrity has been the cornerstone of our success in the Arctic. The map that you have all seen several times now, this shows you ExxonMobil's experience. For more than 90 years, we have been operating in Arctic and subarctic environments. And this North Pole-centered view of the world shows the Arctic Circle and the approximate limit of what we call Arctic conditions. Arctic conditions are defined as areas where presence of ice, icebergs, and/or permafrost affect operations. The red squares show the locations of some of ExxonMobil's Arctic interests and research sites. And now I will start a quick trip through our history, talking about our development in the Arctic before we look at the challenges going forward. Let me start with the Norman Wells. The Norman Wells field is located in the Northwest Territory of Canada, 900 miles north of Edmonton, and was discovered in 1920. The field has been operated by Imperial Oil, a subsidiary of ExxonMobil, since 1932. This field represents the world's first commercial oil field and refinery in Arctic conditions. There are a number of technical challenges. The reservoir itself is located under the Mackenzie River, which is covered by ice up to 2 meters thick for more than half the year. Seasonal flooding, ice jams, and scour by the ice are some of the challenges. To tackle these issues, we have faced the challenge with the use of man-made gravel islands. Exploration in Alaska began in 1965 at Granite Point, located in the Cook Inlet. Drilling and development challenges here include earthquakes and high tidal ranges. In 1966, ExxonMobil installed the Granite Point platform, our first offshore ice-resistant structure. And while no longer operated by ExxonMobil, the platform continues to produce after more than 40 years of successful operations. In 1968, Prudhoe Bay was discovered. This is the largest oil reservoir discovered to date in North America, 25 billion barrels oil equivalent, and it's located 400 kilometers north of the Arctic Circle. A significant number of technical challenges had to be addressed in the development of Prudhoe Bay. One of the most challenging questions was how to export oil from the field's remote location. In the summer of 1969, ExxonMobil led the world's first demonstration voyage of a commercial ship, the SS Manhattan, through the Northwest Passage to explore the feasibility of an Arctic marine transportation system. At the end of the day, a pipeline system was determined to be more cost-effective, but problems associated with the operation of a warm pipeline in thaw-unstable permafrost had to be addressed. Those problems were solved by elevating the pipe above the ground and using heat pipes to transfer heat from ground below water to the pipeline itself in winter. Our colleague from Canada spoke about activities in the Beaufort Sea. Exploration activity in the Beaufort Sea is challenged by a very short open water season. In 1980, ExxonMobil pioneered the use of gravel islands for exploration activities in shallow water Beaufort Sea. This was followed by ice island experiments, which led to the world's largest ice spray exploration island in the Canadian Beaufort in 1989. By spraying water onto sheets of ice, the water freezes, increasing the weight of the ice and forcing it to sink. Eventually, the ice reaches from seafloor to surface, creating a foundation for a drill site. Now, to address the issues of severe ice, heavy currents, and ice scour, 2 gravel production islands have been built. The Endicott Production Island started operations in 1987 as the first offshore production system in the Beaufort Sea, and it continues to produce today. Understanding ice is, of course, essential for safe development in the Arctic. From 1981 to date, ExxonMobil has performed and participated in numerous iceberg studies to be able to predict and determine iceberg velocity, size, mass distribution, and impact load. Among other places, studies have been conducted offshore Grand Banks in Canada, the Barents Sea, and Sakhalin. And these studies have been conducted in cooperation with leading international researchers, including the Norwegian Polar Institute, the Russian Arctic and Antarctic Research Institute, and the studies have led to the development of a number of databases, including the Ice Data Acquisition Program. More recently, in 2011, ExxonMobil carried out the Amundsen expedition to collect data related to surveillance of summer ice conditions in the Beaufort Sea to support development of plans for future exploration drilling in this area. The purpose, of course, of all these studies is to provide information that is imperative to forecast and monitor ice conditions in the vicinity of drilling and production sites. The data allows us to correctly calibrate the risk that ice and icebergs pose to individual Arctic projects and enables us to mitigate this risk in all phases of those projects, from planning the exploration campaign, through designing the facilities, and through operations of a proper ice management fleet. In 1997, the Hibernia gravity-based structure was installed. While strictly not Arctic, this structure is located in the very same part of the world where the Titanic sank 100 years ago, so icebergs pose a very real hazard in this part of the world. Hibernia was designed as the world's first iceberg-resistant gravity-based structure. It stands more than 200 meters tall and is designed to withstand the impact of an iceberg weighing 1 million tons. Now, while it was designed for iceberg impact, in reality, we do not allow icebergs to contact the structure. We have a proactive ice monitoring program, and whenever icebergs get within a certain distance from the platform, we have dedicated supply vessels that go out and lasso the iceberg and tow it away. Perhaps our greatest success as a company in Arctic conditions has come from our Sakhalin 1 project. For reference, Sakhalin Island is located east of the Russian mainland, just north of Japan. And despite being positioned at a latitude similar to Stavanger, Sakhalin Island experiences harsh Arctic-like conditions. Sakhalin has freezing temperatures of minus 40 degrees Celsius, fierce ice conditions half the year, and severe wave and earthquake activities. This makes this one of the most challenging environments where we've ever had to develop a field. At ExxonMobil, we often say that technology is the lifeblood of our corporation, and this is certainly true in Sakhalin. And I want to share with you 2 technology examples to our success. First off, the offshore Chivo field has been developed largely by drilling extended reach wells from a sophisticated land-based rig. Since 2007, ExxonMobil has drilled 19 of the world's 30 longest ERD wells to develop this field from an onshore, ice-free location. A second and more challenging example is the development of the Arkutun-Dagi field. This field is further offshore, and the necessary development wells could not be drilled from a land-based location. So ExxonMobil is developing the field with one of the most technologically advanced platforms in industry, the Berkut gravity-based structure. The Berkut platform is an ice-resistant platform designed to safely operate year-round in a seismically active area to withstand winter temperatures of minus 40 C, waves up to 18 meters high, and sea ice 2 meters thick. The GBS itself was completed in the summer of 2012 and towed to site, and we expect first production in 2015. Through innovative technology and teamwork, the Sakhalin 1 project has achieved tremendous success in a very short period of time, and underlying each of these accomplishments has been a firm commitment to safety. So let me shift gears now and look forward. What are the challenges and issues that we face in new Arctic developments? One essential aspect to development of new resources is, of course, environmental protection. We believe that healthy ecosystems can go hand in hand with economic development. But when we enter new frontier areas, we recognize that environmental and social conditions can be quite different from the ones that we encounter in more mature parts of the world. Let me start with discussing the critical topic of oil spill prevention and response. In 1989, the Exxon Valdez supertanker ran aground in Alaska's Prince William Sound. ExxonMobil took immediate responsibility for the incident and launched a massive cleanup effort. By 1992, the US Coast Guard declared the cleanup complete. And while our mitigations were prompt, this is a tragic accident that the company deeply, deeply regrets. The time following this incident resulted in ExxonMobil refocusing our commitment to safeguarding the environment throughout our worldwide operations. The incident led to the development of our Operations Integrity Management System, a rigorous and comprehensive system that enables us to effectively manage risk within our operations. Prevention, of course, is the first and most effective line of defense against spills, and prevention starts with the design of wells and facilities, the systems and procedures used to operate those facilities, and the training and skills of the workforce. If a spill occurs, the highest priority in response is always the safety and health of the responders and the community, and the extreme conditions of the Arctic make strict adherence to safety protocols even more important. Our comprehensive oil spill response program includes repeated drills and training designed to keep our responders proficient in carrying out their duties. More than 1,000 ExxonMobil employees are involved in oil spill response teams worldwide, with the aim never to have to use their skills. In addition to our practical training, we have been a leader in industry in terms of oil spill response research. We have had a dedicated internal research program for more than 40 years looking at this important topic of our business. Now, one key challenge, of course, in the various regions within the Arctic is the limited data describing the environmental conditions. Therefore, an early step in any project is baseline data collection that will then support environmental risk assessments and design. This can be very challenging. We've talked about remote locations and harsh conditions, but it is essential to gather this data to understand the ice conditions, the ocean conditions, and the environmental background in order to properly assess and manage the risk associated with development in these parts of the world. Sakhalin Island is, for example, home to a unique natural environment filled with diverse wildlife. The Sakhalin 1 project has been involved in the design and implementation of several research programs to study rare and endangered birds and mammals, including the gray whale shown in the picture. Another challenge in many Arctic areas is that there are limited regulatory frameworks in place. Decisions and regulatory frameworks governing the development of oil and natural gas resources in the Arctic need to be efficient and transparent. The oil and gas industry has a key role to play in regulatory development and should be engaged to facilitate practical, realistic, and risk-based regulations that govern Arctic hydrocarbon resource management. Now, at ExxonMobil, we know that making the most of energy development is about much more than oil and gas production. It's about developing people and creating sustainable long-term benefits to local communities. In the initial phases of the Sakhalin 1 project, more than 13,000 jobs were created. And while we've been operating there for less than a decade, more than 80% of our employees are Russian nationals. We also recognize the importance of doing business with local suppliers, and around 2/3 of the contracts awarded for Sakhalin 1 have been to Russian contractors and joint ventures. Now, as you've heard from some of the other speakers, it's been very clear that one of the key challenges in developing the Arctic is the high cost. A number of factors drive that. There is, of course, the huge lack of infrastructure, and Mr. Fox in Canada gave you some great examples of how that plays out in the Beaufort. There are often no harbors, no roads, no hospitals, small populations. The fields are a long distance from fabrication yards, so it's very difficult to get infrastructure to site. The supply chain is incredibly complex, from the basics of food and provisioning for your workforce to providing parts. Everything is more challenging. There are fairly short work windows that are ice-free summer installation windows. The conditions, of course, are very challenging to the human labor force with long hours of darkness and extreme cold. And there's a need for specialized vessels that are capable of operating in these ice-prone conditions. In sum, all of this results in a significantly more complicated and more expensive development and operation than we are used to in more mature areas of the world. One way we can address these challenges, though, is through the development of new technology. Now, I have, in my tour through ExxonMobil's Arctic projects, highlighted some examples of technologies that have been developed to tackle the specifics of an individual project. But it's clear that we're not at the end of this technology journey. Future challenges will require an even greater commitment to developing new technology. I want to share with you examples of a couple things that we're working on today. The Arctic drill ship, and Asbjørn talked about this a bit. One of the key challenges in the Arctic is you've got a very short drilling season. So how do you extend that season? One of the things we're looking at our research center is how to combine available technology elements, such as ice-breaking hulls, azimuthing propulsion, thruster-assisted mooring, and ice management, to position us to have an Arctic drill ship available that could potentially work offshore year-round. This would be a huge breakthrough in terms of drilling efficiency. Oil spill response we've talked about. There are, of course, a number of unique challenges in the Arctic. How does oil move in ice? How do dispersants work in cold conditions? There are a number of questions that we are tackling on this front. Subsea. One possible solution to move away from the ice is to move subsea. But what do you do in areas where ice gouges the seabed? You need to ensure that all of your subsea structures are properly protected. And last but not least, how do you design and plan your logistics in a remote area that is covered by ice most of the time? Ice-breaking tankers and loading terminals need to be developed. ExxonMobil supports collaboration with academia, government agencies, other oil and gas companies, and our contractors to assist in this technology development. And I think collaboration and sharing are key words. We have some great examples from here in Norway. Through the years, we've worked on a number of projects around the world with Norwegian research institutions like SINTEF and Marintek, and we've worked very closely with contractors like Aker and Kværner, and of course have a very appreciated partnership with Statoil, both in Norway as well as abroad. But I think Norwegian concrete technology is a great example. This technology was developed here. It was initially used in the Norwegian sector for fields like Statfjord and Beryl. ExxonMobil has since deployed that same technology to develop Hibernia, the Adriatic LNG terminal, Sakhalin, and the Hebron project that's currently under construction, all led by Norwegian contractors Aker and Kværner. So with opportunities on the horizon, our Arctic exploration and development activities will continue in several areas around the world. I'd like today to particularly highlight our plans in Russia. As you can see from the image here, ExxonMobil has multiple areas of interest in the Russian Arctic. Our initial agreement with Rosneft to explore for hydrocarbon resources in the Kara Sea included more than 125,000 square kilometers across 3 blocks. That's equivalent in size to the total leased acreage in the US Gulf of Mexico. The agreement has since been expanded to include an additional 600,000 square kilometers in the Chukchi, Laptev, and Kara Seas. In 2012, we commenced exploration activities with the acquisition of a large 3D seismic survey and a regional 2D seismic shoot. Drilling of our first exploration well is expected to begin next summer in 2014. And the Russian team is working very closely with our partners Rosneft to make sure that all the logistics and all the challenges and all the risks have been analyzed, assessed, and will be addressed for that drilling campaign. In closing, the past 90 years have demonstrated that safe and environmentally responsible development of oil and gas in Arctic conditions can be successful. The unique and often challenging circumstances require an unwavering focus and dedication to safety, operations integrity, risk management, as well as continual research and development, both for Arctic nations as well as for the oil and gas industry. Through partnership and cooperation with government, industry, academia, and civil society, Arctic oil and gas can be developed in a safe and environmentally responsible manner. ExxonMobil looks forward to playing a significant role in bringing these important resources to market and ensuring a bright future for all those involved. Thank you for your attention.
Thank you, Meg O'Neill. Just one question to follow up that. Based on, you talk a lot about the experience that your company has. From the pictures you see now on the Norwegian continental shelf, the Barents and so on, that we have been talking about today, what do you think, based on your experience, is the biggest challenge for Norwegian companies and regulators to work on just now?
You know, for me, the Barents is interesting because in many ways it's a natural extension of the existing Norwegian shelf. And if you look back over time, a number of wells have been drilled over time, over decades in the Barents. ExxonMobil over the years has been involved in, I think, 18 wells in the Barents. So there is a lot of operational history here. So we need to make sure that we incorporate the lessons and the experiences that we already have in that part of the world and expand it to the next phase of development. But obviously, as I mentioned, you know, cost is going to be challenging. It is remote. It is a bit more difficult. It's farther away from existing infrastructure. And so we need to make sure that we're working together to have sensible solutions that enable cost-effective development of these resources.
I bet we'll all follow your work next summer in the Kara Sea. So that will be very exciting.
It'll be very exciting for us too.
I bet. I'll give you a book as well. And before everybody leaves, I've got 2 messages, so wait for 10 seconds. Thank you very much. A big hand again.
Thank you.